This here is a CNC Hotwire cutter. It's designed to automatically cut out foam shapes, such as aeroplane wings, and it was built by Emma over here.
Hi.
And in this video, you're going to find out all about it, and then we're going to try and cut some wing parts from it. Now, this was built by Emma, as you probably saw in the giant ground effect plane video. So yeah, Emma's going to take you through the whole thing and show how she created this very useful machine for future videos. Okay, so how did you start this project?
So I started this project with a recommendation to check out a guy called RC Keith, who made the Hotwire CNC cutter a while ago, and he's been improving it and putting up a load of tutorials and information online about it. So I found out about RC Keith through Easy Composites, actually. Paul over there recommended us the channel and his website, and that's where we started. This is Keith.
Keith, legend.
So Keith has a website that goes through everything to do with the CNC foam cutter, as well as several videos on his YouTube channel. And on the website there is an ebook as well that you can download. It's £3, but it was absolutely worth it, with a really thorough explanation of how to build this yourself. So all of this, it was even down to template patterns that I could print out and cut myself. He specified which draw slides to get, components, a walkthrough on how to use the motors with the software and the electronics that I'll show you later. It is really thorough, and it was super, super helpful. The build was actually split into two parts. It was the mechanical part and the electronics, and I started with the electronics. Keith recommends that you kind of start with the electronics, so if anything does go wrong, you don't have a fully assembled CNC machine that might go to waste.
It's good. That's smart.
It's smart.
He's done that before.
He's learnt. The PCBs that we used were the Arduino Mega 2560.
Which is which one?
This one here. A Ramps 1.4 board and some motor drivers.
That's very small.
It's tiny. These are DRV drivers. They're the ones that were needed for the motors that I chose, but you could choose different motors and the appropriate drivers. So yeah, so it was pretty standard Arduino Mega. There's no modifications or anything. We just joined it with the Ramps board, which is actually used for a lot of 3D printing. A lot of people that make their own 3D printers will use a Ramps board. But it was perfect for the application that Keith designed it for. It can control several motors, as well as some extra pinouts for heating elements. You can actually power the Hotwire from this board if you wanted, but I needed a longer wire, so I chose to power it separately. When I joined all the boards together, I had this guy here, which is actually our in-use setup. It is just.
So hang on, why have you still got these then?
I may have broken a couple of boards along the way.
I see. So these are actually broken.
Yes.
Yep.
So.
R.I.P.
These ones are very easy to break. They are, you can get them quite cheap.
Well, you would say that.
Yep, that's because we went through three. The Arduino, unfortunately, burnt out because of a problem with one of these boards, which was very sad because these are like £7, I think, and our Arduino is about £50, or €50, should I say. So that
project budget, that was.
That one hurt. So this over here is the stuff that is actually in use, functional and not broken. This is our power supply unit. It's 12 volts, and I've used that to power our Arduino and our Ramps board via the Ramps board. I've also powered some fans through the power supply unit, which is a little bit overkill, but it's just isolated it away from the Ramps board because I can't be trusted with the pinouts. So all of our motors are controlled through that Ramps board and the Arduino and the drivers. And we have 4 motors in total. We have one here, one at the back that you might not be able to see, and then the exact same on the other side in a mirrored configuration. So Keith goes through a lot of the setup process through his YouTube and the ebook, and even on the website for troubleshooting questions. It was so helpful. You start with the firmware on the Arduino, which was easy, and you can also download it from Keith's website. The Ramps board needed very little setup other than the installation of the drivers. and then the drivers themselves there. And you run some tests with the motors before you assemble it, and you check that everything's running fine. Okay, so the next step was the hardware. And I started with cutting out all the MDF parts. I cut everything out on a jigsaw and it went relatively smooth.
Fairly straight.
Fairly straight.
I mean, the good thing is that it didn't need to be super straight on certain bits, but...
Yeah. There's a lot of calibration and alignment you do later on in the build, and it made it very forgiving. But yeah, if you have the resources, I would absolutely recommend getting the MDF parts CNC cut, just so you can, use the edges trustingly to align parts and pieces.
So wait, you need a CNC cutter to make a CNC cutter?
CNC cutter to make the CNC cutter. Okay, so after I got all the wood parts together, I started the assembly. Thankfully, Keith had involved an entire kit list on his website of what to buy, so I had everything prepared and ready, which was amazing. It saves so much time with projects like this. These are actually furniture slides, drawer slides. And yeah, it is what helps the two towers and all four axes move really smoothly. They're all motorized with a threaded rod. So this threaded rod pushes the thread on the inside of this T-nut here, and that is what pulls this part up and down. So it's the exact same process for our two horizontal axes. Our T-nut is here. We have a much longer threaded rod, and that is what moves the entire tower back and forth on these drawer sides. The threaded rod, in combination with the accuracy of the stepper motors, helps you create a really detailed movement. So you can get some really accurate shapes and quite detailed shapes. Okay, so the main part of the setup is the Hotwire itself. And it had a lot of fine-tuning needed. Whenever you change the width of the Hotwire, you also have to change the power supplied to it. And the heat of the wire is dependent on the power supplied to it, and the heat also affects the kerf. The hotter the wire, the bigger the kerf value, and the kerf value is how much space this wire cuts through on the foam. We need this space to be quite small, which is why I've also got quite a small wire. This is 0.4mm nichrome wire. The ideal situation is you have a block of foam that cuts 0.4mm throughout the entire cut.
Because this wire is 0.4mm.
Exactly. Yes, the wire is always going to do a little bit more than the size of the wire because it melts the area around it. But that actually comes in use with the wire on the machine because as the wire moves, it clears its own path. A lot of people, when I show them the machine, they think it's like a cheese cutter and the wire pulls through the foam, but it actually melts a path and it never comes into contact with the foam. The Hotwire is powered separately to our motors by a power supply down here. So this power supply heats up the wire. I chose to do it separately from the board because we're doing a lot of chopping and changing with the machine. I'm changing the wire a lot and it really lets me kind of fine tune the power going through the wire. You can also do this via the software if you power it up through the ramps board. We were doing some really wide cuts and the ramps board does have a limit to how much it can power. We were actually using 29 volts from this power supply on our huge cuts for the Akranablan. The ramps board would not be able to power that.
Right, so that's how Emma built the thing. Now we're going to try cutting some wings on it as a demonstration.
Okay, so first step when cutting a wing on our Hotwire CNC machine is we need the G-code for the wing itself. So this is one of the towers and this is the other tower. What I've done with the machine is I've pulled the wire to where I want it to start and I've set that as my origin. You could have the same origin point for every cut you want to do if you wanted, but I tend to adapt it depending on my chunk of foam. This line at the top of the G-code here is at a faster speed. It's not meant to cut through any foam, it's just meant to quickly move to the front and then cut backwards. So that's why I've started my wire so far up. If I started quite low or at the bottom, it will try and push through the wire at this high speed, and it'll just do the cheese cutter instead of the melt. I've got my power supply powered up, got my fans keeping my drivers cool because they can get quite hot. They do actually have a little heat sink on them, but it's not good enough when it's plugged into a ramps board and running something kind of this power intensive. Yeah, so I'm going to power on the Hotwire with our power supply down here, and then we'll press play over here and run the G-code.
Oh yeah, safety first.
Mask. Okay, powering on our power supply.
See what's happening?
So the wire is fitted when it's cold, obviously. We tie it with a spring on one side because as the wire heats up, it goes slack because hot things will expand. But we need quite a tight straight wire when we're cutting, so we have a spring here that I'll turn it off. We'll tighten and loosen depending on the slack in the wire. So I've just turned the wire off, the wire's going colder, the spring is expanding because the wire is cinching in. And if I turn the wire on, it's going to get hot and expand, which means this spring will contract. And to give it maybe like 20 or 30 seconds to fully come up to temperature, but the Hotwire does heat up and cool down pretty quickly. Fingers crossed this should work first time, but there is a lot of trial and error with this machine. Ready? 3, 2, 1. Oh wait, we can't have the weights on actually. It needs to go over and through. Almost. So it's going through and cutting out our inner chambers first and our spar hole. It's just gone over our foam quite quick, goes straight down in, and it's hollowing out the inside of the airfoil. It'll do this spar hole next, that's where you put a carbon rod or something through, and then it'll do our second lightning hole. So you can see that the lines that it's cutting through are wider than the wire, and this is what I was talking about earlier, where it's melting a radius around itself as it melts through the foam. This is also a problem with calibrating, is you want a high enough temperature that you can get a good speed, that you're not waiting an hour for a cut or something silly, but also too hot and you have a really wide kerf, which means that you can't get pretty accurate details like that little spar hole, or maybe a very specific curvature. So now that it's cut through the lightning holes and the spar hole, it's gone all the way back to the start and it's cutting out the surface of the airfoil, so we get a nice smooth shape to it. Back to the origin.
Ta-da!
Cool. That's our wing. Cool.
So happy with that?
Yeah, very happy. This is one of the examples I did when I was first making and setting up the machine. I actually think this one's a lot better. There's a lot neater cuts to it.
Anything else you want to say?
I love this machine.
Right, so yeah, we're going to be using this machine in a lot of projects going forward. Thank you, Emma, for building this machine. And yeah, make sure to subscribe to Project Air 2 down below for more behind the scenes stuff like this. Thank you very much to RC Keith for the plans. And yeah, hopefully this video encourages you to go and check out Keith's YouTube channel. Thanks very much for watching, and yeah, see you on the next one. Bye for now.